Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He's passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. Thank you, Rashmita. I'll quickly share my screen. Okay, so guys, let's get started. And good evening, everyone. Hopefully, all of you are doing well at home. You are safe. And today's session is on HTAP as such. We will be talking about hybrid transactional and analytical processing solution with Azure services. So what we'll do, we'll first understand what is the meaning of HTAP. We will understand why it is there, what was the need of it, what is the logic behind it, or the various components as such, and then we'll see how to deploy it. So I have one small reference diagram over here, which I just want to show it to you. So the HTTP solution is not that it is something new which Azure is providing. It has been there in the, you can say, in the world since a long time. But we provide the solution with the help of Azure Cosmos DB. And there is a concept called as Azure Synapse Link and Synapse itself. So we'll see what are these components, how to work with it. We will also see one scenario. I have one demo of a bank as such where the data is streaming and we will be doing some real-time analysis on the data, and we can also do batch analysis on the data. So let's get started. And I'll give you a brief about it, little background, and then we'll jump into the code itself. Okay, so check this out. Okay, so let's start from why do we need it. So basically, I'm pretty sure that you are aware of that we have two type of systems as such. We have OLTP systems and we have OLAP systems. So the OLTP systems are responsible for running your businesses. These are databases as such. So if you're aware of Oracle, or if you have worked with SQL before, or if you have worked with any other relational database before, then you have already worked with the OLTP system. So imagine there is a business, maybe there is a website or something, and transactions are going on. So all those transactions are being registered over there in a table as such. Now, whenever you run any business, it's not only about just running the business. You also have to analyze the business. If you can do the descriptive analytics on the data, if you can understand that why something worked out or why something didn't work out historically, then you will be able to gather more insights into what can be changed. For example, rather than sending, you can say, some rather than sending some blanket emails promoting your product, you may like to target the customer based on their you can say behavior or user pattern or their likes and dislikes as such. So analysis is always required. So the systems where we are doing the descriptive analytics or reporting or BI or historical reporting as such are the OLAP systems over here, the warehouses as such. And the job which moves the data from here to there is the ETL job. So this is what happens today. We have OLTP systems, we have OLAP systems, and this is from where you can do your reporting. So let's say I have few reports created over here. Now, it works great, right? But let's try to optimize it. Couple of things which we are aware of is that the OLTP systems are row oriented. The OLAP systems are column oriented as such over here. So what is the meaning of it and so on and so forth? We'll just come to that in a few minutes. Now these are column oriented. The ETL job which is running in the middle, that adds complexity. That is another job which is running that also adds, you can say, delay. Whenever the job will run, then only your data will move from OLTP to OLAP. So that is somewhere we can think about any improvements that something can be done in place of that ETL job, or how can we reduce the time of it. So I'll just say it's a delay over here like this, right? So OLTP systems and the OLAP systems, and there is a ETL job is moving data from here to there. Okay, so what is this row oriented and column oriented? That's the most important thing. Now, whenever we talk about row oriented, if I just try to represent a table over here. So let me just try to fill up some values as such. Let's say this is your table and it is having few values over here like this. Now, when this data will be stored at the page level, so these tables are just logical in nature. The data is stored at the in data pages as such. So when the data will be stored in at page level, the data will be stored basically in row manner. So if I can make one data page over there, so imagine this is one 8 KB data page, very small, right? And you have millions and billions of data pages. So data is stored over here in row manner, something like that. Okay, so how is the data stored in the warehouse? What is that column oriented nature of data storage? If I just try to represent that, now data is stored, the columns are stored as rows over there. So data will be stored something like that, right? This is a very high level. Understand, this is a high level representation of column stored, but that's how your data will be kept. So let's create some more data pages over here. Now, what is the importance or what is the use of storing data like this? Whenever we are doing whenever you are working with the transactional databases, the requirements are that you want to retrieve few records, maybe one record or few records as such. Whenever we are working with the OLAP systems, the requirement is that you may have to read billions of records of hundreds of columns. So if you're storing your columns together, logically you will be able to, you have to go to less places to retrieve your data and you will be able to load your columns way faster and all the millions or billions of rows which are there historically stored in the warehouses. Now, okay, so things were working fine till now. Now let's try to see what can we do on top of it. So the word HTAP is a system which is hybrid system and it is created, or it is a system which is the hybrid of of OLTP plus OLAP, and we will call this hybrid transactional and analytical processing system. So it is a type of system which can do transactional processing. It's a type of system which can do analytical processing at the same time. So how is that possible? How do we do this in Azure? And what are the details about it, right? So I'll just see if I can create something over here. Now the few solutions or the first solutions where Microsoft has introduced the HTAP concept is with Cosmos DB. In future, they may work with they might be working with you can say might be working on more services. So what is Cosmos database? Now FYI, Cosmos database is a semi-structured database. It's not a relational database. It is storing. It's the one where we have four modes we can store data as documents, we can store data in a key value pair, we can store data in graph mode, we can store data in Cassandra mode. So there are various modes in which Cosmos DB works. So and in Cosmos DB, what happens, we have a namespace label which is global, and inside the namespace we have the various endpoints, and these endpoints will be in the Azure region. So Cosmos database is a distributed database and it provides multiple type of consistencies as such. So if I just try to represent Cosmos DB with few circles over here, so check this out. So imagine this is my Cosmos DB and it is having the databases are there in three regions and everyone is syncing with everyone. Okay, let me see if I can just do something like that. So everyone is trying to sync with everyone like that. Now, okay, so this is a semi-structured database. Okay, now Cosmos database is a semi-structured database, but it is a OLTP database. it provides multiple consistency, including strong consistency, which is not the focus for the day. But what happens over here, if I go to my Cosmos DB, I'll see if I can just zoom in. So let's say I'm trying to show you that. Let's say we are zooming in over here. Now, if I try to make Cosmos DB, let's say this box is representing that one region, and this one region can be East US, like that. And this is the box which is representing that East US. We'll try to see if we can have a look inside it. Now, let me take you to my Azure portal and I'll try to do something on the way and I'll explain it as such. So this is my Azure portal and I'll just take you to the Cosmos DB as such, which I'll zoom in first for all of you. Okay, check this out. So this is one Cosmos DB which I have. I'll click on it and we will click on the Data Explorer over there. Or before I click on the Data Explorer, I want to show you one more thing. You see this feature. So if you want to work with the HTAP concept, you have to click on the feature and you have to enable the Synapse Link. What is Synapse Link? I'll come onto the Synapse Link in next 2 to 5 minutes. So first of all, you go and you enable this. Now, second thing what you have to do is you come to your Data Explorer and we would like to create a database. So I have this database over here, Woodgrove. Now inside this Woodgrove, I can create containers. And those who are new to Cosmos DB, containers are exactly, or containers are equal to tables in your relational databases. And rows over here are equal to items as such. Items are documents inside the containers. So I have this database and inside the database, I have 3 containers. So if I can expand that. Okay. So, okay. So we have, oh, sorry, we have 4 containers over there. Metadata, suspicious transactions over there, transactions, and another one which I just have created just to show it to you. We are not using it. So what happens? I just want to create one container. I want to show you something. So let's say I click on container. I may have to create another database or I use the existing one. That's fine. But if I scroll down and if I click on this article store over here, then if I enable that, right, which I have enabled for the containers over there, then what happens is something like this. So Cosmos DB internally will, you can say, break into 2 pieces or something. We can put it like that. One will be OLTP and one will be OLAP, like this. So the OLTP one will store the data in row manner, just like we just talked about few minutes back. And the OLAP is the one which will store data in columnar manner, which is more suitable for analytical purpose because you would like to read lot of, you can say, uh, rows of many columns as such. Now, apart from this row oriented and column oriented, there is also an auto sync which is there between them, like this. The value of this auto sync is somewhere near 2 minutes. It's somewhere around 2 minutes. So in 2 minutes, the data will be syncing from OLTP to OLAP. So first thing which I would like you to focus on is that the movement of data from your system which is running your business to the system which is doing the analysis now can be reduced to somewhere near 2 minutes, like that. Now, secondly, more important things which are there is that we will be able to set different performance levels over there. What do you mean by performance level? So imagine that this OLTP part was being used by the production system right now, and you go and you start running one analytical query which reads a lot of data. Now, if that query runs over there and it consumes a lot of data, then the resource which is allocated to the database supporting the production system will be now divided between your multiple queries as such. So that will impact your performance of the OLTP part, but it doesn't happen over here. So we can specify different request units for this and different request units for that. Now, request units are simply, you can say it's a combination of CPU, it's a combination of RAM. These are basically resources. Now, if you just want to remember 1 KB per second, if you want to read 1 KB per second, that is equal to 1 request unit. When you write 1 KB in 1 second, that's equal to 5 request units. So just like a ballpark figure. Okay. Now, basically, I can specify different request units so, or resources over here for the OLTP part and different resources for the OLAP. So it doesn't matter how big a query I run from the OLAP, it will not impact my system which is supporting the business right now, which is pretty interesting. Now, I'll do one thing. So I have this simulator with me. So I'll just quickly show you the VM. Okay, so the scenario which we are looking at is that the scenario is of a bank called as Woodgrove, and that bank is looking for uh, a HTAP system, and with that HTAP system, they want to do real-time analytics and they want to do some batch analytics on the data. So when the data is streaming from the transactional data which is coming will be on the real stream, we have to do real stream analytics, and over a period of time, maybe once in a day, once in 7 days, and so on and so forth, we have to do batch analytics on the data. So I have started the simulator which is streaming the data to my Cosmos DB right now, and this will keep on running for next many minutes. We'll just minimize it. So if I just try to tell you what has happened is that there is a simulator over here which is trying to stream transactions right now. So we something like this, and it is streaming a lot of data like that, right? Like this, something like this. Okay, now how do I do the analysis on top of it, or where is the compute engine? Cosmos database is a database. It will store your data. It's a semi-structured database. It will have OLTP and OLAP parts over there. Another very interesting thing is we can specify different time to live for them. Like you can have a different TTL here and you can have a different TTL here. So in case you want to move your data or you want to store your data in the hot part for some X amount of days, you can specify all those details, right? Now, where is the compute engine? This is a database over here. Now for the compute part, we know that one of the best compute engine is Apache Spark. If we can use Apache Spark, we will be able to run our stream queries uh, as such. And because of the serverless manner of the cloud, or because of the pay-as-you-go model which we have in the clouds, when your batch queries will execute, the servers or the Spark cluster will be deprovisioned, so you don't have to pay for it. And I'm pretty sure you're aware that Spark queries are somewhere around 10 to 100 times faster than the Hadoop queries. So Spark is able to do both stream analytics and batch analytics in the clouds as such. So the next thing is, can we have a Spark cluster where we can run the jobs? And then another thing which comes to mind is that if we have the data which is very big in size and it's on a distance from the compute engine, and then the data gets copied from the database to the or goes to the compute nodes as such, then because of the network or the distance which is between those servers, how much latency will be there? That's another very important thought which comes to mind. So, so let's check this out. So what Microsoft did is Microsoft has created Synapse Link. Now, in simple words, Link is a high-speed network connection which is there inside their data center from the servers where the Cosmos DB is hosted to the servers where Synapse is hosted as such. So this neck which I'm trying to create over here, this is Synapse Link. So Synapse Link. And we have to enable it. So I went to the Cosmos DB, and in the configuration, if you remember, I was showing it to you that you have to enable the link. Now, once you have done it, let me see if I can make a little more space over here for me to put something over there. Okay. Now, this is where Synapse comes into picture like this. Now, in Synapse, we have multiple. Synapse is a suite of product, right? It's not a single solution as such. It's a suite of product. It has four main things over there. You can have a warehouse inside a dedicated SQL pool. You can have Spark clusters over there, that too in serverless mode. We can also have uh, the serverless SQL pool, which is used for EDA purpose, or we can also have the Synapse pipelines, which are the ETL and ELT pipelines. So this box is representing my Synapse right now over here. So if I just want to show it to you once before I come back and continue. So let the data stream, but let's find the Azure portal first. Okay, so this is how Synapse looks like, and this is created in the same region. I have both of them in the same region. Obviously, it will be next to the data. Now, we have various things over here. You can have a look at it. We can manage the linked services from here, the connection configurations and different things. Monitor is something which is very important. When things will not run, you will come to the monitoring section and you will figure out that why it is not running or why it is taking time, or what is your basically in Spark we have various components. Stages are there. We want to see the DAG diagram. We want to see the how much resource utilization, how many executors are there, all of those type of information you'll find from the monitoring section. Now integration is the one where we have the ETL and the ELT pipelines. I may have something over here. So you can create some ADF type pipelines to move data around. Now in the develop section, so if I go to data first, so this is where another interesting thing about Synapse is that you will be able to connect multiple uh, storage solutions of Azure, and you can manage it from one single location. So if I create multiple linked services, then I will be able to see all those things listed over here. So Cosmos DB is there. Few of the data lakes are also there. In the workspace section, I can see a few more resources are there. So if I go click on any one of them, okay. So okay, let me click back on the manage part. So in the manage part, if you can see that Apache Spark pool, new pool, we need to create a pool over here. This Apache Spark pool is when you create that. So for example, if I fill up this information over here, I say Apache Spark pool 3 or something. Then I can also specify that am I looking for isolated compute? Isolated compute basically means that at the backend, the servers will be dedicated just for me or not. So if I say isolated compute, they are dedicated for me. But when we do that, the size of the VMs which we can go for are the big ones. So if I click on the node family, if I click on the node size, the large sizes will be there in the isolated compute. So let's create something. Okay, so this is 03. I have 01 and 02 already in place. So this is 03, and we can specify auto scaling, number of nodes, and the how many executors will be there, or they will increase automatically or not. What is the pausing time, so that it will automatically deprovision after the 15 minutes of idle time. You can play with that value, which Apache Spark version is there, and other details. If you want to have some configuration of Spark given through the file, you can also do that. Now, once you create it, tag is just a billing concept. Once you create it, what happens? You don't pay for it. So if you create it, it just shows like that. But just to create that, it doesn't create a cluster. It is just like a configuration or context, or it's a more like a configuration which is there. So when is the cluster created, or where is the computational part? So I'll just click back on the develop section. I have few of the notebooks over here. We'll see what are these, and I can just see. So this is the Spark pool 01. And let me just confirm that the stream is still going on or not. If there is no stream, there is no stream analytics, right? So stream is still going on. So before I can go and show you all those, check this out. So inside the Synapse, we will have the Spark pools over here. Now, whenever you will run the jobs inside Spark, then the cluster will be spinned up for you. So you don't pay for just creating the Spark pool. You pay when your job actually starts executing over there. The minimum configuration is one head node and two worker nodes. Now, so this is one of my Spark pool. You can have multiple. So now the very interesting thing which we have is that if you want to do real or you can say stream analytics, and in the scenario which I have deployed or which I'm trying to explain right now, there is a transaction going on, and you have to find whether the transaction is a fraud transaction or not in real time. So real time really means that the customer who is paying for the food somewhere in the restaurant will not be waiting for you to give the result back after 2 minutes or 3 minutes or 4 minutes or like that, right? It has to be as fast as possible. And one of the benchmark, which if I remember correctly from Microsoft, is 2 seconds. That was with the Azure Machine Learning Studio. You can just look up you can say look up in any of the search browser. You'll find the benchmarks which we have. Okay, so what I can do is I can read my data from the OLTP like this. I can say cosmos.oltp, and then that actually means that we are reading data from the OLTP section, and this is where the data is coming in real time from all the transactions which are going, and the simulator is actually writing the data over there like this. And this is where your job will run. Let's say this is representing my PySpark notebook, or the job over there. This is the cluster which got spinned up once you start executing the job, and the output basically. So the job is supposed to find the frauds over there. And just one more information which is pretty useful for you is that the OLTP section is read write, and the OLAP part is read only. So if we find any suspicious transactions, then we are supposed to write those suspicious transactions in the OLTP section back, something like this. So I have another container where the job is basically putting the outputs like that, like this. Now, and whenever we want to do the batch analytics, so now if you think it through, the hot path which I'm creating right now, right, the from the OLTP system over there, that hot path is going to be having very less data. Like in if you think about stream, very less data will be there. Now, when you think about any banking scenario, uh, it is there are multiple thought processes over there. Like one thought process is that uh, instead of frustrating the genuine customer by blocking their transaction, right? It is better that you let few of the frauds pass and in a batch mode you catch it and then you take care of it. So in the hot path, and we also know if you do something very fast, you cannot do it properly. So in the hot analytics, anyways, there will be some limits which you will be hitting based on how much you can say what's the time of your query execution over there. So in the batch mode, what we can do, we can read those that let's say once in 7 days, we are getting the data from the OLAP part over here. And maybe the same cluster is used, or maybe that cluster is used by someone else. So maybe there is another Spark, serverless Spark pool over here. So this dotted line actually is representing serverless Spark. So, and then when you start running your job, this is the cluster got spinned up. And so once in 7 days, you can simply say Cosmos dot OLAP and specify the name of the container from where you want to read, and your job will be running in batch mode, finding the frauds. Okay, one more thought which comes to mind is that how are we uh, sort of doing what is this job, how is it finding the details and all that. So now I'll show you that I have it configured for you. But before going in that direction, basically what you see in the screen is the entire HTAP configuration which you can deploy with the help of Cosmos database and with the help of Azure Synapse Analytics and the Synapse Link over there, which provides that high speed network connectivity between the inside the data center like this. So what you have in the screen is HTAP, where we have the compute part, where we have the transactional systems, where we have the OLAP part as such. So now the job which we have over here. Now it's so this is now what is supported over here. If we think it through, right? You can write PySpark jobs, you can write Spark SQL jobs, you can write .NET Spark jobs over there, or you can write Scala jobs over there like that. So what I have done for you is basically this Woodgrove Bank is having historical data. Like they have historical data with them. I'll show you the data in a second. So it is somewhere over here. So we are working with these three files as such. So the data scientist of the company basically have access to these three files: untagged transactions, account information, fraud transactions, and these are details of various columns and all the things over there. So transaction IDs are there. We have the currency code, conversion rates are there, shipping address, the which type of CVV verification happened and what was the output of it, whether whether it got verified, not verified, error came or whatever. All the details are there. This is historical data. It happened in over last 10 years like that, and they have gathered. Now, so let's just have a look at a couple of more interesting things. So browser type, which type of browser was used? What was the payment instrument type as such historically? Which IP was of which state? Which when was the transaction done? Maybe there is a particular time where more transactions are done, and so on and so forth, or all like that. So we also have information about the accounts as well, like the is the account created how what's the age of the account, like the bank account. So is it created maybe in last 30 days, is it created in last last week itself, or when was it created, like that. So we have all the information. So now I would just like to show you the capabilities of what you can do with a solution like this is, so let's say this is your ADLS, right? This is your data lake, and inside your data lake you have the historical data over there. And data lakes don't have any limit, so you can store any amount of data on top of it. And I'm pretty sure you're aware of the delta lake concepts also. If not, then I think we did one session few weeks back. You can have a look at that session on Delta Lakes. So that is also supported in Synapse, just FYI. So now this is your data lake and you have historical data over there. Now we have Azure Machine Learning Workspaces in Azure itself. So this is the AML workspace. So what I have done over here is I have basically registered that ADLS location into my machine learning workspace. So if I take you to my AML workspace and click on data stores over here, uh, and if I click on the first one, which I have registered, this is the Woodgrove storage. So data store is like so the data lake is now registered in the AML workspace by this name. So we can refer to this inside inside the ML job over there. Now, then I have also created few of the compute instances over here. This compute instance is the development environment. You can also create compute cluster, which is the where the model will train. Now, the notebook which I have is somewhere in this section, and I have already opened this notebook in the Jupyter editor for you. So it is somewhere over here. Now I have two different type of machine learning models which I created. One is the batch scoring model, and the other one is the real-time scoring as such. And different approaches, different machine learning algorithms were used. Different type of tuning was done on this model. Now, so today is not the ML day, but basically, once the model got trained, the model is registered in the model repository or the registry over here. So these are the models. So what we are doing is very smartly from there. So this is the model. The latest model is here. So in the job, we are doing is we are pulling that data model from there, the latest one, and then we are reading the stream from the Cosmos database, the Cosmos dot from the OLTP section. Uh, okay, let me see if I can wipe it off. And then we are doing a model dot prediction on top of it. So model dot prediction will throw the outputs as such, and we have a binary classifier over there which will tell us whether this and we have two classes, fraud or not fraud, and all the suspicious transactions will be stored in another container, and which can be handled by the bank or the engine or the system which is processing those transactions over there. So I just want to show you how are we doing it. So let's go to Synapse. Everything is connected now. And okay, so let's zoom in first. And okay, and let's also see if the stream has stopped. Yeah, okay. So let's start the stream again. Now, basically, when you click on that, right now what is happening? The cluster is coming up. Uh, one head, two workers, and it will take a few minutes for it to be up. You can see how much time it will take practically. Now, apart from that, I'll just take you to the main sections over here. I'll zoom in more. So first of all, we are connecting to the machine learning workspace, and these type of capability is a you can say sort of generic capability which all the solutions will provide. So using Azure machine learning, you can say workspace, we are connecting to it. So this is workspace.create or get. If you don't have it, you just get it. So we are loading the model from there, and these are the functions which we have defined, and this is my workspace. This is information about my subscription resource group and the name of my workspace and in which region is it right now, East US. And then do I want to get or create the workspace? So I already have created it, so it will just get it. It won't create it, right? And I will provide you all these links in the chat window as well. So after this session, please go and try the HTAP concept and let us know about it. So the model which is there, we are saving the model, we are depickling the model, and we are locally storing the model as such. And then once we have done it, we will be doing some, so the data which is coming in real time. See, the machine learning model was trained on the historical data, which is like already, historically where the frauds were and not. But the data which is coming right now, it doesn't have a target over there. It doesn't have the label over there. It doesn't have the you can say you have to find the label. You have to tell whether whether that observation or whether that data or whether that transaction is fraud or not. So if you have done some cleaning on the data during the model creation over here, then similar type of data processing is also required during the uh, during your model.predict. So that is what we are doing over there. So now once we have done that, we don't want few columns. So there are few columns which are pretty interesting, but those are just added by Cosmos DB to find the versions in the data. So we do not would like we don't want to have these. We don't have any logic around that entity tags and all that. It's like used to find whether you are doing. If you know what is optimistic concurrency with E tag, we can do that. Now, so if I just show you the main section. Okay, so this is the main part over here. So what we are doing is we are reading one stream. This function will be called later on, but we are reading the stream. So sorry, this is the right one. Let me show the read part first. Okay, yeah. So this is the read part. So spark.read stream format OLTP. So this is the one where I have that arrow from on the top, the red arrow over there. So this is that. You can just specify that do you want to read from the OLAP part or OLTP part just by specifying it in this manner, OLTP like this. Now we are reading from the Woodgrove Cosmos database, and we are reading from a container called as transaction. This is where the streams are going in right now as we are speaking. And we would like to read from the beginning over there. And there is a checkpoint in case, let's say you have read till line, some particular line, and next time from which point onwards it should be read and all that, right? So that stream is started over there. Is the stream running? Yeah, true, great. Now, what we are doing is basically on that stream, we are running the functions which we have defined earlier. So let's go back and have a look at it. So on top of that, we are just okay over here. So on top of it, we are just doing it for each batch. Like we are getting a micro batch from there, and then if I can just show you the major part, this is where the predictions are going on in the model.predict part. So the model which was historically trained is doing the prediction in this point in time, and then the streams are going back, or the you can say spark.write.format in the OLTP, where in the Woodgrove database in the suspicious transaction we have to write it. So the streams output are going back in the Cosmos DB, where somewhere over here, if I can click and show it to you. So these transactions are right now suspicious as per our ML model. Let's click on one of them and have a look at this. Now, okay, so this is one of the suspicious one. Now, can I do this in a batch mode also, or how will it look like if I do it in a batch mode? There's a stream going on and it's continuously will keep on running, right? Now, if I just show you the other notebook which I have over here for the batch analytics, and we are doing the same thing. Once in a blue moon, you run your batch job. So you are supposed to load the ML model. So we are doing the same thing. We'll load the ML model one more time. And once the ML model has been loaded from the workspace where the data scientist has saved it, and we will be depickling the file. We'll open it up and we will start reading the data from. We'll do the same data processing on the data, because if you teach your model physics, you have to ask questions on physics only, right? So similarly, we will be doing the same type of processing over there. Now, apart from that, we would like to uh, run. So this is how we are reading in the batch mode. And if you can just notice that by just specifying Cosmos DB OLAP from the same database, from the same container, we are able to read from the OLAP section where the data is in stored in columnar manner. And that's the transactions will be read from there. And on top of it, we'll do the model.predict, and we will be putting the output back. So this is where the fraud transactions are being detected. And then we just have a look at it. So how many suspicious and non-suspicious values are there? So this is the count of it. And then we will be able to visualize it as well, like uh, what is the score which has been done, and can we just put the output back in the Cosmos DB. So if I can zoom out slightly so we can see the console slightly better, you can put it back like cosmos.oltp. Remember that the OLAP part is only read. It's read only. So you have to write back in the OLTP section. So what I have just shown you is one thing which you can do if you are working with the HTAP concept in with Cosmos and Synapse, which is there in the screen right now. what other things comes to mind, right? So if I just start copying few of the very nice looking graphics from the link which I'm going to provide you after this session and just zoom in for you. Okay, so this is one example where the data is coming for supply chain analytics, forecasting, and reporting. So we have a data factory getting the data from on-premises or from other clouds and so on and so forth in batch mode, right? So this is doing that batch ingestion of data. And on top of it, we have some telemetry data which is getting streamed from these IoT devices. Let's see if we can just make it slightly bigger. So these are where your IoT devices are there, and it's not there, but somewhere over here we'll have IoT hub also in the diagram. Then let's say there is a stream analytics job which is running uh, which is running a query on the windowing function, and then this is the Cosmos database which we have, and Cosmos database is right now uh, already that they have enabled the HTAP part. So this is transactional. That's the analytical column store over there. That's the auto sync. And then you can do analysis with Spark. The ML part I have just shown you. That is similar to that. Now you can also if you there is another thing which is there called as serverless SQL pool. So if you do not want to make a cluster, but you still would like to you want to explore your data from the raw storage locations like data lakes or from the Cosmos database. So then you can run the queries directly on top of it. This is something which is very interesting. It's very similar to the external table concept in Hive, but not exactly. But that type of thing is what is happening there. So then we have the reporting done on top of it. I have not configured it today, but you can check out the links which I'll give you. So you can also create the Power BI dashboard, and then you can embed the Power BI dashboard back into Synapse itself. So this is one example. I'll just pick up another uh, graphics from there. Okay, so check this out. So another use case with HTAP will be something like this, where we are doing the uh, the shoppers are there, and this is what we were thinking about that. Then if someone is shopping on my website right now, if I can show them some relevant recommendation rather than showing them something which is more associated with the products, or if I can just target my customers, I will be able to increase the basket size. They will purchase more as such from us, and we will definitely show them relevant data itself, right? So something which they may be needing, or they may like it, or you if you think that the customer is more likely to purchase if you provide a small discount, then dynamically on real time you if you can do that, that will be great. Like find the value of the discount, and you based on your customer's life cycle cost, you can just see whether it is applicable for them or not. Something like that is going on over here, where B2C is used for the authentication over there for the end customers in the e-commerce website. And then sorry, that's the e-commerce website over here. And then the recommendation APIs are running in Kubernetes, and the order processing API is there running in the Azure web API apps. And then we have the Cosmos DB, which is providing the real time, you can say, OLTP and OLAP support for the entire system. And you will be able to find let's say if someone is purchasing uh, have these 5 things, or you would like to personalize what they see in the page to make their experience better. uh, this is where the real-time analysis is done the way we have done it. Your query or job will change, the rest of things will remain same, and Synapse Link will be somewhere over here. And then you specify the output goes back in the OLTP container, and the Kubernetes API is basically reading from there, and you can say publishing or it's dynamically the pages are getting updated for each individual customer in real time. So this is another very useful example. And something else which comes to mind over here is something like this. So if I just put another picture over there, so this is the one where we are doing predictive maintenance using anomaly detection for IoT devices. So when you're getting your data from IoT devices, if you can properly, let's say your IoT devices are sending you noise or vibration related data, or maybe maybe temperature as such, right? So if you know what's the if vibrations are what you are getting, if you can find the forced vibration from the natural and the free vibration, if you can find that forced vibration anomaly from the data, you will be able to find the micro tear which has happened in the in wherever that device is there, maybe in a conveyor belt or somewhere. And if you can find that the because when vibrations are there, it's not possible for us to differentiate just by looking at the graphs as such, because all the three type of vibrations will combine together, and then you have to find whether this is coming just because the conveyor belt is running faster, or is it or is the anomaly there because there is a micro tear and it is going to break after 3 days. So if you can find that, you will be able to do preventive maintenance, or you can just do predictive maintenance as such. Maintain it before it goes down. So the data is coming. So this is where the ML models can run on the IoT edge itself. And that's IoT Hub, Stream Analytics. That's the same HTAP we talked about. That's the this is the Spark where we are running it, the serverless Spark pool. So then the Azure APIs are there for doing other type of things. Power BI dashboard, ML part of the solution which we have done. So this is another example of where HTAP can be used. So this is what I had for the session. And please go ahead with your questions. Let me see if there are any questions in the chat window. And I will also provide you the link to be done if you're interested in the chat to learn more about HTAP in Azure. Okay, so there are a few questions in the chat. Let me go through that. Okay, let me just scroll up. Let me see if there was a question before it or not. So, okay, what is the difference between the analytics done in the Stream Analytics versus Synapse Analytics? Synapse Analytics will let you do the analytics with on Spark. It will provide you the Spark functionalities. So you will be able the you can say the engine is Spark engine over there. The Stream Analytics solution, it runs TSQL queries, and we can further you can say enhance the capabilities of the TSQL by using JavaScripts. That's not really Spark. It's a proprietary Microsoft solution, and the name it's their own internal research. Like when the world was making Spark, Microsoft was working on their own internal solution, and that finally became the Stream Analytics. It's fundamentally different. Now, when should we use which one? That's another thought which comes to mind. So, what Stream Analytics does is it has pretty interesting windowing function concept. We have similar windowing functions in Spark, but these Stream Analytics jobs are, you can say, sort of more straightforward. The maintenance will be less. The difficulty of creating them will be less. You don't have to manage your Spark cluster and all that. It's a very well maintained 24/7 running job, but that cannot do batch analytics for me. That will only be a stream job. So with Azure Synapse Analytics, I can do both. I can do stream jobs as well as I can do the batch jobs, batch analytics as well with it. So there are hundreds of technical differences, like what are the connectors which are there, what can that connect to. Stream Analytics has very nice connectors. You can just click in and input and output, and then it connects with all the locations as such, and then you will be able to work with it. And here also we have the similar capabilities. So if your job is simple enough or you can say can be configured in Stream Analytics, go for it. Otherwise, go for Spark-based solutions where you can do anything which comes to mind. Okay, so others, if you have any question, please go ahead. Let me know.
Yeah,
The
sure.
link is in the chat window. Yeah, yeah, Dinesh.
I couldn't see the chat window. Maybe I missed to log in. So like, can I? I'm just asking. Okay.
Yeah, sure.
Shimam, I have two questions. First question is the OLAP part. Like from OLTP, the data is converted into columnar format and stored for OLAP, right?
Correct.
Can I connect directly that OLAP with Power BI? Why should I? Why this Azure Synapse is needed?
Okay. So why is Azure Synapse needed from the reporting's point of view, right?
Yes, because Azure Power BI has a connector for Azure
Correct.
Cosmos DB, which
Correct.
directly puts the JSON data as it is into Power BI,
Correct.
where
Correct.
people do the parsing of JSON columns and so different things.
Correct.
So why can't I connect the OLAP portion, that portion directly with Power BI and do my reporting and all those things?
Okay. So a couple of line of thoughts over here. One thing which comes to mind is that just when the data is stored in the OLAP section, it may not be in the format, or it may not be aggregated enough, or it may not have the you can say the correct structure. It's just columnar in a sense. So the reports which the Power BI connector which is connecting to the Cosmos DB uh, may not be the most appropriate thing to do in that point in time. What else comes to mind is that we will also be able to create the external tables over here in the using uh, the serverless SQL pool. So these external tables will be pointing to the containers which you have there or in the OLTP part, and then and these external tables are simply you can say they don't have any data, they only have schema, and this on top of it we will be having the Power BI dashboard connecting to this external table. So it will be providing that same functionality in a way in which we are managing the schema over here, and these external tables will be created after the analysis which we have done, and or maybe they can be a combination of various different columns or tables and so on and so forth. So it will be more, you can say, aggregated for me. Otherwise you can directly connect to uh, Power BI dashboard to Cosmos DB itself. But the analysis part, the compute engine part, all of those functionalities are there in Synapse.
Okay, understand. And second question is, let's consider that I have the structure, uh, structure of JSON data to be more complex in OLTP, in Azure Cosmos. Consider that the levels of JSON data is many levels are there. So while that sync is getting happen within the 2 minutes sync and conversion into OLAP, can I control what portion of data to be stored into OLAP?
Okay, now if I just enable the auto sync over there, it's going to you can say then my control of what can be done will not be to the same extent which you are looking for. And the second thought is, if I have nested files, we have explode functions. We will be able to you can say uh, explode the nested JSONs and will be able to handle it. But then there, if you just go for this auto sync, the amount of control comes down. Then
Okay.
what else can we do? We may have to think of other solutions. You may would like to maybe read from OLTP, run some jobs, then write back in OLAP, or sorry, then write back in the transform your data in the OLTP section, which is syncing with the OLAP, or use something like maybe data factory or something where you are doing, or maybe Synapse pipeline where you are running your jobs in the way you want.
Okay. Okay. And that explode function, you mean we can use in the Synapse portion, right?
Yeah, in the Synapse portion, correct.
Okay. Okay. Thank you.
Right. Okay. So there is another
Hi,
question in.
sorry,
Yeah,
can I
please.
ask one more question? One
Yes,
question.
please go ahead. Yes.
So you mentioned something about when you were mentioning difference between the OLTP and OLAP. You mentioned something about rows and columns.
Correct.
And sorry, that time I got dropped, so I couldn't get that. And then I saw there was some diagram where you mentioned a value A and all this. So can you, if you don't mind, can you please repeat it?
Correct. So okay. Now, so the fundamental difference between the reason why we would like to store the data in row format in transactional databases versus the columnar format in the analytical processing system. The most fundamental difference or the reason is that how the way data is stored physically at the page level as such. So when we store in row format, if this is my table, so tables are logical assets, right? That's not how data is stored really at the page level. So imagine that's the 8 KB page which I have, very small page over there, but one of the data pages looking like that. So when that table will be, you can say, stored or when that row will be stored in that particular 8 KB data page over there, then of whatever amount of data goes in it, it's a pretty small size of 8 KB page. But if you can see that the rows are stored as it is, like if I can just represent ABC, it's going in that same manner. So what's the good thing over here? So if any query comes, let's say the customer goes back into the front end and he or she clicks on the historical orders. So now and would like to see whether the order is scheduled, when it will be delivered, is it stuck in custom, is it you can say if any issue is there with the order and so on and so forth, right? So whenever the person goes and clicks on it, the query will be fetching that one record or maybe few records over there, which is pretty practical for that scenario. But let's say I have a data engineer or maybe a data scientist over here who would like to, or maybe a data analyst who would like to analyze why things have worked in on a very big size of data of last 3 years and so on and so forth. Then the if we store the data in row format and you try to read some X number of columns from those millions or billions of rows, then that retrieval of data will be very slow. So what we do, we store it in the most logical manner. We store the columns as rows because when we do analysis, we will not only be reading you can say few records, but you will be doing something where you have to read maybe 100 columns out of 1,000 and 1 million rows out of the system over there. So if you can store this in one location, that will be great. Another analogy which comes to mind is, let's say I want to buy grocery, and if all the things which I want to buy is available in the same store, then the time of my retrieval will be less, rather than going into multiple stores and getting the data from there. So if I want to read this entire column, that entire column will be in some X number of data pages, and we will be able to pull that very fast. So that's the fundamental difference between row and column oriented. And in analytical systems, column oriented solutions will be there. Like we have Parquet files which are column oriented. So this is what we were discussing at that point in time.
Okay, so does it mean that suppose I have a row like some example, say students data, right? Let's say example student ID, name, and age, and all the stuff. So I'll be putting everything in the column. Is that something we are talking about?
Okay. So let's say so this is some X1 column. This is X2, X3, X4, X5. This is your let's say X2 is the student's name, first name. X3 is the last name. X4 is the uh, let's say let's think about e-commerce. So imagine X2 is first name, X3 is last name, X4 is the last item which was purchased, and other purchase history which is there. Now you would like to know that when next time this person logs in, or you will not be running that solution just for one user. You just want to cater all the users which you have on your platform. So now and you just assign one, let's say this is you where you are doing the data science, and you have to retrieve some you can say features out of this data, not the noise. Everything doesn't make sense in data science, right? We would like to have the features which will make the system run better. So imagine out of those thousands of columns which you have, you would like to read uh, some 5 or 10 or 100 or something. But because you are doing analysis on historical data, you will be having millions and billions of rows. So this huge row which you have, if you store it in a in so if the columns are stored in row manner, I'll just correct myself. If the columns are stored in row manner like this, I have to go to less number of data pages to retrieve it. The retrieval will be fast. So think it through, let me know. Okay, so any other question which comes to mind?
Okay, so just got it that, okay, in that case, we will be storing all, but in that case, my columns will be, because columns I'll be storing as a row. So rows will become column, and then it will be huge, isn't it? I mean, that's what is the confusing.
Repeat that statement one more time.
See, when my columns
Yes.
becomes row, as you showed that I'll be storing in the manner which is vertical. Yeah. So automatically my rows will be, because I had millions of rows, so that will go into the tables and I mean, that's the confusing. Yeah. So that will become my columns, right? Because column will become row, but row will become column then. And then millions of columns. I mean,
Okay, so the let's go back to that same analogy of the grocery store. So imagine we wanted to buy maybe some millions of things as such. So now if those millions of units of uh, stuff which you want to buy is available in this X number of grocery store versus billions of grocery stores, then retrieval from this X number of grocery store will be very fast. You will be able to go and get it from there. Versus you going to each and every, you can say billions of data pages and you are finding that particular column number X3 or X4 or something and you're fetching that one value, that will be so slow. So the way the data is organized, like that makes a difference in the retrieve of how fast can we retrieve it. So think it from that analogies point of view. And yeah, this is big data. The bigger the better. We have Spark clusters. We will create a big cluster, and we'll be able to handle it. The size of data is not the major issue. Then what next thing which we can think of is, if the data is so big, can I do partitioning over there? Can I do indexing on top of it? Can I do distributions on top of it? So how can I make sure that my queries are running faster? So we have, if you have that problem, we have more solutions for it. But that's the way it will be stored.
yeah. Thank you. Thank
Right?
you.
Okay.
Good guidance. Thank you.
Okay. Okay. So okay, then the link is going in the chat, guys. I am also putting my LinkedIn profile in the chat. In case you have any question which comes to mind, feel free to ask. And please join us for the other sessions also. And you can join the Reactor group. My profile is going in the chat. It is also in the meetup page, and I'll also give you the module to be done. I think Rashmita has already pasted that.
So Shivam, this is Murali.
Yes, go ahead.
I am into more of development stack, not in the data part. So I'm just interested to see the use cases. People who are new to data science and this big data. So can you just give me one or two links where we can find the use cases of how to link our, for example, let's say we have a SQL database and how can we link it to this kind of big data and streaming kind of things. Maybe one or two use cases which would direct the beginners more in the right direction, like towards this data science and big data stuff.
Okay, do you have any particular, so which domain do you work in right now? Which industry as such? If you have any, you can say inclination towards, let's say I want to maybe mm, want to see how IoT solutions can be integrated with whatever we are doing, or any other thought like that.
So I'm just working as a developer, and I'm more comfortable with the banking or mortgage kind of domain.
Okay. Okay. So one thing which I'm doing is the best location right now from where anyone will be able to self-learn is MS Learn, the link which we are providing. So if I'll share one link in the chat in few seconds. So for example, let's say any one of you would like to learn something new as such, then the link is in the chat now. You just open that one, and it's the search window is there. Around some 3,000 tutorials are there, and these tutorials are very. It's not like just a junk over there. All these tutorials are somewhat, we can say, related to scenarios. And on the left hand side, there is a section where we can select the learning path and the labels of whether are we can say we want to see advanced scenarios or beginner or intermediate scenarios. And there is also a differentiation between the roles as such, like I'm a developer or maybe a data analyst or administrator and so on and so forth. So you select that and it will shrink your search result. And with that, we will be you will be able to find what you're looking for. And there are very nice scenarios there. Type bank over there and see how many scenarios will be there on it. I can see 11 result came. Have a look at that last link and do the one before it, the one which we have shared for today's session.
Thank you, Shivan.
Right, okay. Okay, then I think Rashmita, we can wind up. If there are any more questions, guys, just let me know. Or you can find me on LinkedIn as well, and feel free to ask your questions.
Sure, I think we don't have any more questions, so we can wrap up the session, Shivam. Thank you so much, and thank you all for joining us today. Please share your feedback about today's session. Also, please feel free to use the Learn module link shared in the chat section. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.